Hello everyone, welcome back to another Mia lecture. Today we're just going to talk a little bit about complex numbers in Python and how they work. So just a question, have you ever taken an Uniques class before? It's okay if you haven't, but something that's really interesting about Python, at least using this sort of package, is that actually complex numbers are represented with a J instead of an I. Kind of funky. This happens with a lot of electrical engineers, pesky electrical engineers. They like to use J's instead of I's. So unfortunately, that is how Python works. So when you use this package, know that a J is your complex number. CMath is kind of a really nice package to use here. It has all of the things that you need for complex numbers. So we're going to import that. Now we're going to do something fun. We're going to create a complex number. Here you see we're going to create a complex number by putting the real part plus, whatever your complex part is. And of course, again, that is represented by J. You don't have to do J dot anything or CMath dot J. It knows from that package that J is an imaginary number. So make sure you don't call anything else J because it's already there. This is just some code to show you how you can index for certain types of things. So if you create something like Z that is a complex number, you can do Z.real and that will show you the real part. And you can do Z.imag and that will show you the not real part, the imaginary part. So that's one really, really useful tool if you're trying to unpack what is real and what is not, especially with more complicated things. So that's just a really helpful tool. The next thing that is pretty cool is you can actually convert to a complex number without doing any arithmetic. So if you are like, okay, I want to have x is -1 and y is 0, and you want -1 to be your real part and y to be your imaginary part, you can actually convert that into a complex number by just putting in z equals complex xy, where y again is what you want your complex part to be, and x is where you want your real part. And if you print that out, you can kind of see here, it creates that complex number for you. So that, again, super nice, especially in terms of like formatting and kinds of things. You don't have to create things. It can create stuff for you. Now we're going to get into more of some stuff that you heard in the lecture. We're going to talk about conjugates. So when you're trying to find the conjugate of a complex number, actually there's a really nice thing in CMath where you can do whatever your complex number is. So if you create it, you do 1 plus 2j. You can actually put that number, so in this case it's z, but z dot conjugate, and it will create it for you. Again, remember from that lecture before that the conjugate is just your real part minus your complex part in whatever form that is. So that's really, really nice. And another trick that you can use complex numbers for here in Python is going from complex to polar. So you saw this in your graph that Tim pointed out in the lecture, which is, if you plot real versus imaginary and kind of having those things, it's really, this also deals with Eulers. So, when you're trying to go from like cosine to polar and all of these different things, it's really useful to have that conversion from complex to polar. So Python's got you. If you do cmath.polar and you input any complex number, it will convert that number to polar, which is quite useful. So now we're going to do some examples of some other cool things that we can do with this other stuff. So if we have, let's say, z, which is our complex number, which is 1 plus 2j, and we have its conjugate, 1 minus 2j, if we want to add them together, we can just do that simple arithmetic like you would do any two normal numbers, and that will work. If you want to take the magnitude, this was something that Tim talked about in his lecture, but instead of having to go through kind of that arithmetic, you can do z times z prime, multiply those two together, and Python will do it for you, which is really, really nice. Again, if you want to actually find the magnitude from polar, they actually have that as well. There's a thing called cmath.polar again, and if you add in this magnitude into here, you can get the magnitude in polar, which is really nice. If we print all of these things out, here we get our answers. So again, if we add them together, we have 1 plus 1, which is 2, and then 2 minus 2, which is 0. If you do the magnitude, again, that's where you're multiplying these two together. You will get 5 plus 0, and then again, polar, you get 5 and 0. So that's pretty cool. Now actually dealing with Eulers, let's take a look at some of the cool stuff that Python can do. So again, if we start with our initial complex number 1 plus 2j, we can actually do cmath.exponent of z. And this is, again, kind of what you are learning in terms of Eulers, which is that, you know, cosine plus some version of sine, and then that's equal to e to the plus or minus I theta. And so we can quickly use this to convert this into some form of that, and you can also, again, you know, find that conjugate pretty easily. So then you have these numbers, and it's great. You can do so many things with this application. It's awesome. Then for one last quick example, we're going to add two waves using complex numbers. Now, Tim might have mentioned this in the last lecture, but complex numbers are really, really useful for representing waves. They're obviously used in a lot of like electrical engineering applications, a lot of stuff over there as well, especially I think with circuits and things. So here we're going to do that. So we're going to use math here as well. So we import this package. We're going to have wave 1. We're going to make that just one some amplitude with e to the something j, and then we'll do a second amplitude, again, just kind of picking a little bit of like random things here, except this one is pi over 2, so it's a little bit different with that amplitude. Then we're going to add those two waves together, and again, remember, this is just simple addition, which is super easy, and it does that separation of arithmetic for you, which is really, really nice. So, and then if you want to get the magnitude and phase of the combined wave, you can do that super easily just using, again, this cmath.polar and taking that addition of it. So if I print this all out so you can see everything, you have your first wave in that very easy readable context. Then you have your second wave also in that nice context. And then you can get the combined wave. Then you have the magnitude of the combined wave and the phase of the combined wave. So again, all of these tools are really, really useful, especially in material science and some other applications. I hope this is useful. I hope it's useful in your homework, and I will see you in class.